This video is sponsored by Brilliant.org, but more about that towards the end of the video. I don't know about you, but I spent a lot of time as a kid playing arcade games, and one of my all-time favorites was Frogger. If you somehow don't know how Frogger works, you are a frog who is trying to make it home. But in order to get there, you have to cross through high-speed traffic and over an alligator-infested river. And although this task might look simple at first glance, there is a lot of strategizing involved, because it can be difficult to time your movements correctly. So this game seems like the perfect candidate for the AI treatment. Now, the last game I did this with was Geometry Dash, and in order to do this, I recreated Geometry Dash from the ground up, and then built the AI. And I am going to be doing the same thing here, except this time it makes much more sense to do this. This is because there are dozens of versions of Frogger that I could use, and since they are all written in assembly or other languages, it seems nearly impossible to try and integrate an AI into it. So in this first video, we are going to be building our own version of Frogger from the ground up. So without any further ado, let's get started. Now, just like with any game I make, the first step is writing out some boilerplate code. If you don't know, boilerplate code is the code that we need in order to get things working. And in our case, this involves writing out code to open, update, and close the window. If you use a game engine, this is almost always done automatically for you. But it's more fun doing things the old-fashioned way. Since we are now done, if we run the code, you could see that a blank window is created, and we could close it as well. Now that we have a window to make our game in, it's time to actually make it. But before we write any more code, I decided to make the Frogger map. To do this, I borrowed a sprite sheet of the game from online, and then I manually constructed the map from a couple of different tiles. The map I created is exactly the same as the original, except that I decided to make each side a little longer, so that it could fit better onto the screen. Then from there I wrote out some code to load in the map and to render it. Now, since the map still doesn't fully cover the screen, I decided to make up a blurred version, and then render it underneath the actual map. And here's what it looks like. If you're wondering why I left a little space on each side when I could have made the map even bigger, besides looking cooler, once we start implementing the AI, I want to be able to have a spot on the screen to display information, and not have it cover up the map. Since we now have our map done, we can finally start implementing some gameplay. But this will require some entities. So I got to work writing out an entity class. Now, Frogger has a couple different entities. There is the player, the vehicles, the logs and turtles used to cross the river, and a couple of other entities that are used later on in the game. So I had to write this class in a way that could easily accommodate all of them. Now, in order to render these entities, I made up a simple texture atlas to store all of the entity sprites. This is convenient because it means I don't have to load in dozens of textures. Another nice feature of this specific texture atlas is that I put sprites that are related to one another in columns, so that if I need to create an animation, all I need to do is to change the vertical offset of the texture I am currently displaying. Now, getting back to the code, I made it my priority to focus on getting the frog to be able to move around correctly. But I forgot that moving the frog one unit isn't one pixel, but rather one tile instead. After I resolved this issue though, you could see that the frog is now able to move properly, and it smoothly transitions into the tile that it's jumping towards. Now, the next kind of entity that I worked on was the vehicle entities. Frogger has a very simple traffic layout. There are 5 lanes at the bottom of the map, and each lane has its own exclusive vehicle, as well as alternating the direction that the traffic flows. Somehow, just like with the frog entity, I managed to mess up the speed of these entities as well. And this bug ended up revealing 2 new issues. One is that the truck is split in half, and kind of looks like a Minecraft half bed. And 2 is that since I render the entities last on the screen, they actually render over the edge of the map. So to fix this, instead of rendering the entities on top of the screen, now they instead get rendered onto a texture that is the size of the map, and then that texture is rendered on top of the screen. So now everything looks better. Since we are now done implementing the traffic, let's turn our attention to the river. Now, the river is a lot more complex than the traffic is, and this is because there are a couple more entities we have to worry about. The 2 main ones though are the logs and the turtles. The logs are the main entity that is used to cross the river, and they always move to the right. The turtles can be used to cross as well, but some of the turtles are able to duck their heads underwater, which can be a problem if you're standing on top. Implementing the code for both of these entities was actually pretty straightforward though. I think this was because of the experience I gained from implementing the vehicles, since they're fairly similar. And if you want to gain some experience, especially with programming, then you should check out this video's sponsor, Brilliant.org. If you are like me and have a passion for learning and developing new skills, then look no further than Brilliant. Brilliant is a learning website that is the best way to learn math, data science, and computer science skills in a fun and interactable way. Gone are the days of large and overwhelming courses. Brilliant's unique approach breaks down complex subjects into bite-sized modules, perfect for even the busiest of schedules. Spend just 15 minutes a day and you'll be able to grasp essential STEM concepts in no time. And if you're interested in learning about programming but don't know where to begin, I personally recommend the new Thinking in Code course, because it gets you designing simple programs to solve real-world problems right from the start, so that you could start building intuition that will last a lifetime. To access everything that Brilliant has to offer for free for a full 30 days, visit brilliant.org/codenoodles or click the link down in the description below. And if you are one of the first 200 people who do so, you will get a full 20% off of Brilliant's annual premium subscription. A big thank you to Brilliant for sponsoring this video, as they allow me to keep doing what I love for you guys. But now, let's get back into the project. Alright, both the logs and the turtles have now been implemented, and if I step onto either of them, you could see that I move along with them. The only thing that is missing though, is that if I jump into the water, I don't die, and it's the same way with the traffic as well. But luckily, this was a pretty easy fix. All I had to do is to check a couple of different conditions that result in death, and if any of them are true, to kill the player, and render a fancy animation. Now that we are able to die, it seems appropriate to finally implement a way to win as well. And this involves making it so that the frog can land into the homes at the top of the screen. And to do this, I wrote some code to detect if the frog is inside one of these positions. And since this code uses the position of the frog after it's rounded to the nearest tile, you don't need to be perfectly aligned with the home to land in it, just close enough. Since we have most of the core gameplay mechanics down, I want to turn our attention to the bottom of the screen, where it seems like something important is missing. And that thing is the UI. To get started on implementing this, I wrote out a text renderer, so that we can quickly and easily display information. And then from there I began writing out code for each individual part of the UI. Alright, everything is now done, and you could see here at the bottom of the screen that we now have a timer that shows us how much time is left to make it home, as well as the number of lives left. I know that the score is missing right now, but I'm running out of time for this video, so I'm scrambling to get things done. While I was at it though, I also made up a little pause menu that will come in handy a lot in the next video. Anyways, I really hope you guys enjoyed this first video of this little mini-series. Sorry if you expected there to be some AI action right out of the gate. I just need a game to apply the AI to, before I can actually make it. Either way, thank you guys as always for watching and for your wonderful support, and I will see you in the next video. Bye-bye!